Hello, my thoughtful teenagers, and welcome back to another episode of Grade 10 Maths with me, Miss Lambert. Yes, we are still on the topic of algebra. It is a very big topic though. But for this lesson, we're going to be looking at factorization. Now, what exactly is factorization? Let's see if we have a definition for that. Yes, we do have a definition for the term factorization. It says, the word factorize means to write in the form of a product using factors. Now let's read that again. You can read with me. The word factorize means to write in the form of a product using factor. The product of x into a plus b is equivalent to xa plus xb. Now that is if we use the distributive law. But if we factorize xa plus xb, we're basically looking for the common factor that appears in both algebraic terms. And in this case, it is the letter x. So when we factor out x, we have a plus b. Now, I know you might be asking yourself, what is the relationship between the distributive law and factorization, or expansion and factorization? They are basically the inverse of each other. Let's continue to look at this thing called factorization. Here you can see we have some examples for you. So let's go through this example one at a time. So taking into consideration our first algebraic expression, which says 6x squared plus 3x. Now we want to simplify this by factorizing, and we said to factorize is to write in the form of a product using factor. So if we look at this and that, we're going to see that there is a common factor. So we can first deal with the common numeric factor. So the common numeric factor would be 3, because 3 can divide by 6 and 3 can also divide by 3. Now if we look for a common algebraic factor, it would be x, because x appear in both cases. So we have 3x. Now if I am to divide 3x by 6x squared, I have 6x squared. This can then be written as 6 multiplied by x, and all of that is divided by 3 multiplied by x. So 3 into 3 is 1, 3 into 6 is 2. This x will cancel out that x, so I have left 2x. And if I am to factorize 3x and I divide that by 3x, I will get 1, so I have plus 1. And that is how we simplify this algebraic term. Additionally, let's look at yet another example. So here we have 12x squared minus 8x. So remember I said we first look for the common numeric factor. So if we look here, we cannot divide 8 by 12. So we need to think of another number that can divide both of these numbers. So from looking at it, we know that we can use 4, because 4 is both divisible by 12 and 8. So we have 4. Now we're looking for the common algebraic factor. So the common algebraic factor would be x. So we have 12 multiplied by x all over 4 multiplied by x. So 4 into 4 is 1, 4 into 12 is 3. X and x will cancel out. So we have 3x remaining. Now let's look at the other one. We have 8 multiplied by x divided by 4, that is multiplied by x also. 8, 2. So now we have minus 2. So we can see that when we factorize 12x squared minus 8x, we are going to have 4 into 3x minus 2. Let's continue by looking at one last example. So here we have minus 8x minus 6x squared. Now, in all of the other examples that we looked at, we did not have a scenario where both of our values carried a negative sign. So when we're looking for factors, we need to take into consideration our sign. So before we do that, let's try to find a numeric factor. So if we look at both of our algebraic terms, we're going to see that a numeric factor would be 2, because 2 can divide by 8 as well as 6. And our algebraic factor will be x. And we're going back to our signs, which will be negative. So there we have minus 2x as our common factor. So I have minus 8 multiplied by x divided by minus 2 multiplied by x. So x and x will cancel out, and I have minus 8 divided by minus 2. And directed numbers need to be applied here because we have signs, as we may call them. So if I divide negative 2 by negative 8, I'm going to have a positive 4. So I can have 4 here. Now I have to focus on my second algebraic term, which is minus 6 multiplied by x, because I have x squared. And I'm dividing that by minus 2 multiplied by x. So my x will cancel out with my x, and I have 2 being divided by 3. So 2 into 2, 1. 2 into 6 is 3. Positive 3 at that, because my negatives will also cancel out. So I have 3 and I also have x. So this is positive 3x. And here you would have seen my answer if I would have factorized this. And this is some example of how you can factorize algebraic expression. We are continuing, and yes, we are still on algebra and factorization, but now we are looking at how you can factorize quadratic expression. And what is a quadratic expression? Now if we look here, we're going to see something that looks similar to a topic we touched only recently. Yes, expansion of binomials. So when we expand two, or we expand a pair of binomial, we end up with a quadratic expression. And a quadratic expression is an expression in x or y, even a or b, basically any letter of the alphabet, where the square is the highest power. So here you can see that we have the square as the highest power. Now if I am to distribute using my FOIL method, I will end up with what is at the bottom here, and that is known as a quadratic expression. So here you're going to see the general representation of a quadratic expression. Now if you're going to factorize a quadratic expression, it is similar to the factorization we were looking at in the earlier parts of this lesson, except you need to do it 2 times. Now when you look here, let's look from this step right here. From this step here, we see that x squared plus bx plus ax plus ab. Now when we are factorizing, there is something that is very, very important. Now when we extract the common factor from the pairs of algebraic terms that are close to each other, whatever appears in the first bracket must be duplicated in the second bracket. So if you look here, you're going to see that x into x plus b plus a into x plus b. So both our brackets were duplicated. Now we represent that by writing the elements outside of the bracket in one bracket by itself, and since both brackets are the same, we simply write it back once. Now let's put some numbers in these places so we're going to have a better understanding of what we are doing. Here we have x squared plus 3x plus 2x plus 6. Our example says x squared minus 5x plus 2x minus 10. Now remember I said that we all time pair our algebraic terms when we're working. So our common factor in the first pair is x. And when I factorize that, I'm going to have x minus 5. And I do the same thing for the second pair. I look for the common numeric value first, or the common numeric factor, which is 2. And I can see from right to this point, I have no common algebraic factor. So I can go right ahead and factorize. So I will have x minus 5. From here, I can rewrite by writing my 2 factors that are outside of the bracket together in one bracket and then that in the other bracket. Because it appears twice, we just rewrite it one time. This example says that x squared minus 5x plus 2x minus 10. Now we are factorizing, and remember, when we're factorizing, we do them in pairs. Let's take a look at another example. Here we have x squared plus 4x minus x minus 4. Now here we have x squared plus 4x minus x minus 4. We do the same thing again. We pair our equation and we simplify. So from the first one, we're going to have x as our common factor into x plus 4. Now if you look here, we have to find a common factor, but there is also a common sign that appears, which is negative. So when we look here, we can find a common factor between both of them. The common numeric factor would be 1. Now why this is important, remember, whatever appears in this bracket, we must have the same thing in the second bracket. So working from this, if we divide negative 1 by x, we're going to get x. And negative 1 divided by negative 4 will give us positive 4. So here you can see that both of our brackets are the same. So we can rewrite this by writing our values outside the bracket first. So we have x minus 1. Please remember to take into consideration your sign. And x plus 4. So there you have it, how we can simplify or factorize quadratic expressions. Now that we would have looked at that, let's summarize our lesson. Now it says that the word factorize means to write in the form of a product using its factor. Here we are going to see that if we add xa plus xb and we factorize that, we would have taken out the x and we would have been left with x into a plus b. If we had the quadratic x squared plus a plus b x plus ab, when we factorize that, we would have been left with x plus a into x plus b. Now I want you to have some practice on both of the set of problems that we looked at. So what you're going to do for me is reference Mathematics, a Complete Course with CXC Question Volume 2. For the first set of problems, I want you to go to exercise 13F, which can be found on page 731, and you're going to work questions 1 to 7. Now once you would have done that and you have gained more confidence, what I would like you to do is go to exercise 13E, which is on page 733, and work for me questions 1 to 31. Now once you would have been able to complete all of those problems, I am positive that you will have no worries in factorizing any algebraic expression or any algebraic term given to you. So please ensure that you reference and practice. So my thoughtful teenagers, there you have it, our lesson on factorization. We did look at simple algebraic expression as well as quadratic, which is also an algebraic expression. Please remember to practice, 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 because I want you to be able to solve any algebraic factorization question that might be thrown at you. I am Miss Lambert, thanking you for being here with me on this episode of Grade 10 Maths. I will see you next time. Do take care. Bye bye.